Hey, how's everyone doing back now? This is the video for Chapter 7, Lesson 7, on solving actually just solving two-step inequalities. Now, just like the previous lessons, it all is the same exact thing over and over again. A two-step inequality, just like an equation, is a math problem that has two steps, two operations involved in it. And this time, instead of an equal sign, we're dealing with an inequality symbol. That's the only difference. Everything else will behave exactly the same as it has before. And let's just go ahead and jump right into it. Let me go ahead and apologize now if my voice sounds like I'm talking into a tin can. That's because I'm in a room that has a bit of an echo, so please bear with me. But as always with these videos, if you miss something, you can always rewind it and go back. And of course, if you still don't get it, feel free to ask a question. So let's begin today's lesson. Example 1. Solve 3x plus 4 is greater than or equal to 16. Graph the solution on a number line, or the solution set on a number line. So I'll go ahead and begin with my blank screen, not that. So here we go. Let's get this going. Okay. Now, what we need to do first, as always, is to rewrite our inequality all over again. 3x plus 4 is greater than or equal to 16. I'm going to draw a little divider here now because I'm going to do some other work on the other side in a little bit. So I'm going to go ahead and do what I showed the students, and that is to do a little t-chart. Let's talk about our variable x. Well, first we see that x is being multiplied times 3. So it's being multiplied times 3. I'm making a little chart here to help me keep track of all the things happening. After x gets multiplied by 3, it then gets added by 5. So plus 5. Now, I need to figure out the opposite or inverse operations of these two things because that's what's going to help me solve the problem. Well, the opposite of multiplying by 3 is dividing by 3. And the opposite of adding 4 is, you guessed it, subtracting 4. These two steps down here are going to be the steps I use to solve for x in this inequality. So let's go ahead and begin. The only question you really might still have is, well, which one of these do I do first? On page, I believe it was page 534, we were told that when you're solving these kinds of problems, you always want to do the addition subtraction stuff first. So between these two steps, the only one that has to do with addition or subtraction is this minus 4. So I'll go ahead and subtract 4. One of the mistakes I've been seeing is that people want to put a minus 4 underneath everything. In this case, the minus 4 would only go underneath the number where you got it from and the other side where your answer is. Those are the only two parts that get the minus 4 in this example. Notice I did not touch the 3x underneath it at all, so it's going to go ahead and just fall right on down. Plus 4 take away 4 is 0, so 0 is the same thing as nothing, so I'll leave this exactly blank with nothing there. My symbol can go ahead and come on down exactly as is, because I'm not multiplying or dividing in this step by a negative number. 16 minus 4 is 12. All right, so I did this first step. Now all I have to do is this next step, which says divide both sides by 3. So I'll go ahead and show that now. We use the fraction bar, or vinculum as it's called, and we will divide by 3. 3 divided by 3 is a 1, so I have 1x left over. Since I was dividing by a positive number, this symbol will not switch at all, so it'll stay the same direction. And 12 divided by 3 is 4. So to tidy this answer up, x is any number that's greater than or equal to the number 4. I'm going to show that on a number line, so I'll go ahead and subdivide this again, and I'll make a pretty small number line. Here we go, because I don't have that much space. You have more space on your paper, so you can make yours a little bigger. Mine has to show that x is any number greater than or equal to positive 4. So since I'm dealing with positive numbers, I'll start off with 0 over here on the left. 0, 1, 2, 3, 4, 5. Here's 4. X can be any number that's greater than 4 or equal to 4. Because it can be equal to 4, I'm going to use a closed dot. So basically, whenever you see the half equal sign there, you're always going to have a closed dot in your graph. Now, all numbers greater than 4, well, that's everything in this direction. And it goes on to the right forever. And of course, I can check it, plug in points and check it, and it will work. Those are my answers. That's how you do this. It's exactly like we did in inequalities. Now let's go ahead and move on to our next example. And as always, if you have a question about something going on here, please write it over here on the side where your notes go. Anything you've learned that's new in this problem, you should make a note of it over here. Anything that's concerning you, you should also write in this area so we can address it in class. Otherwise, let's go ahead and progress right to the next example. So I'll clear this out. Let's go ahead and scroll down. Okay, so now we have another two-step equation here. And I'll go ahead and get this set up now. Let me take everything out. One tool there. Here we go. All right. So, moving on. We have the inequality. Solve 7 minus 2x is greater than 11. Graph the solution on a number line. Once again, write the inequality nice and big, just as you see it. Then, we're going to go ahead and talk about what's happening to our variable x. X is being multiplied by a 2, but really what's happening is that this minus sign turns into a negative now, so really x is being multiplied by a negative 2, which I'll show in parentheses here. Now we also have it's being subtracted from 7. So that's going to be a little tougher to show, so I'll just put that it is being subtracted by 7. Now, I'm going to make a little special note here on the side because this problem is a little different, and I really like this. Subtracted from 7. 7 is not being subtracted from this. It's being done to the 7. So I'm going to write it like this, and there's a reason why. First of all, to make this a lot easier, we know our goal is to get x all by itself. So we're going to have to get rid of this positive 7. It's positive because there's no minus sign in front of it, or a negative, so I know automatically this is a positive number. So ask yourself, how do you get rid of a positive 7? Well, you subtract a positive 7. So I'm going to go ahead and do that. I'm going to subtract 7 from the left-hand side and from the right-hand side, because my goal is to get rid of everything that isn't a letter. So 7 take away 7, this is 0. So this goes away to nothing. Now the subtraction sign turns to a negative and this falls down. Negative 2x falls down together. My symbol still falls down. 11 minus 7 is 4. So now I got rid of that 7 part, and now I can go back to doing my regular rule. What gets rid of multiplying by negative 2? Dividing by negative 2. All right, so now I'm going to divide both sides by negative 2. But we just learned in the last lesson yesterday, that whenever you have an inequality and you multiply or divide by a negative number, this symbol has to flip directions. So now, negative 2 divided by negative 2 is 1x. 4 divided by negative 2, well, a positive divided by a negative is a negative. 4 divided by 2 is 2. So now x could be any number that's less than negative 2. This is what I have to graph. So I'll go ahead and make a little number line over here on the far right. X is anything smaller than negative 2, so I'm dealing with negative numbers. Now notice that there's no equal sign here, which means that negative 2 is not an answer. It's just where the answers all start. And everything smaller than negative 2 is this direction. And I can continue on into negative infinity forever, always getting the right answer. So, in this example, whenever you have a standalone number on the edge, get rid of it just by subtracting it from both sides of an inequality. That's the only trick. These two examples are probably the only thing that's new to you guys in solving these types of problems. Everything else you've already experienced in this chapter and should not be too difficult. If you have any questions, please write them on the side so we can address them in class. If not, I'm going to ask that you guys go ahead and go to the bottom of this page and work on the Got It, A and B. Show your work on a separate sheet of paper. Make sure you grab your solution on the number lines here and write your answers on the side. And if you have any questions, feel free to ask us in class. Once again, if you're confused about when the sign changes, here's a little note on the sign. Remember that if you multiply or divide by a negative number when you're solving inequalities, if you don't remember what inequalities mean, that's any math problem that basically has one of these symbols in it. then that's an inequality. You always reverse direction. The minute you're multiplying or dividing to solve an inequality, you will switch the direction of your sign. Good luck with the Goddard's A and B, and I will see you in the next video.